Okay, so let's continue with sampling distributions with sample proportions and do an example. So according to the Center of Disease Control and Prevention, 18.8% of school-aged children aged 6 to 11 years were overweight in 2004. Notice it didn't give us anything. It didn't tell us the population is normal. It didn't tell us anything, right? So we have to go ahead and do those preliminaries, part 1 and part 2. So let's go ahead and do part 1. Part 1 is making sure that our distribution is normal. So if we need to calculate NP times 1 minus P. So we do know that the proportion of school-aged children that's overweight is 18.8%. So at least we do know the population proportion, which is 18.8, so 0.188. The next thing we need to know is the sample size. So the sample size is not given here, but if we look a little bit lower, we'll see that we're taking a sample of 90. So we'll go ahead and use 90 here. So if we want to calculate it, let's calculate 90 times 0.188 times 1 minus 0.188. And let's see what that is in our calculator. So 90 times 0.188, and I'll just use a parenthesis and 1 minus 0.188. And close it and hit enter. And so I get 13.7, which is definitely greater than or equal to 10. And so we can, this is verified, and we can assume normality. The second part is to ensure that the sample size is no more than 5% of the population. Sorry. So if our sample size is 90, is that going to be no more than 5% of all school-aged children 6 to 11 years old? So 90 children, think about 90 kids. That's about 3 classes in an elementary school. Do you think that's less than all 5% less than or equal to 5% of all children 6 to 11 years old? I think so, definitely. So definitely. And so now these two criteria, part 1, are satisfied. The next piece would be going to part 2 and now discuss the distribution. So the distribution here, we first talk about the mean with respect to the sample proportion. So we do know that the population proportion is 0.188. Since we found that our population is approximately normal, that we can go ahead and assume that mu sub p hat is 0.188. The other piece of information is of the distribution is the standard deviation with respect to the sample proportion. And so that means that that's going to be equal to the square root of p times 1 minus p over n. So in this case, p is 0.188 times 1 minus 0.88 over n, and then we take the square root. I try to leave this exact as possible even when I enter in the calculator, but if you did put this in the calculator, you should get something like 0.0412. Okay, so those are the two pieces that we'll do first, and then now we're good. Notice we haven't even started a problem. We just did the preliminary work. So now this proportion, it fits the criteria of a population being approximately normal, And we have a distribution for sample proportions on the right in part 2. But these two parts you will have to do, and I do expect you to know them, especially when it comes to homework and the quizzes and the exam. Okay, so now let's go ahead and just start a problem. I'm so excited. So in a random sample of 90 school-aged children, 6 to 11 years old, what is the probability that at least 19% are overweight? So we already have all this preliminary stuff, so we're all good to go with part 1 and part 2. So we can go ahead and just start like drawing and do the problem. So here the population proportion goes here. So we put 0.188. For the standard deviation, remember we add and subtract 3 times to the left and to the right. And so I had done this ahead of time just to save time in class. So 0.229, 0.27, and then 0.312. And then 0.147, 0.106, and then 0.064. And so these are also percentages, right? We could move the decimal over twice. So when they give us that, they want us to find that the probability that the population proportion is at least 19%, so 0.19. What does that look like on our graph? Well, we have the tick mark, so we can draw this. So 0.19 would be pretty close to that median, right? And let me go ahead and shade that in. At least would be to the right, right? Because least means greater than or equal to. Okay, well, it actually ends up being the same exact normal CDF because it's a normal distribution. So we're going to have normal CDF. And then you do area, I'm so sorry, left and right. So left is 0.19. Right is all the way on the tail, so 1E99. The mean we can grab from up here, 0.188. And the standard deviation, well, I'm going to actually use the exact standard deviation. It's actually not too bad with our calculator because it's nicely formatted. So I'm going to go ahead and leave it as 0.188 times 1 minus 0.188 all over 90. And then square root. I know I'm going to put that all in. It's crazy. Okay, so let me go ahead and put that in the calculator. Go to second vars, normal CDF, and the lower would be the 0.19. The upper is 1E99. The mean is 0.188. And the standard deviation, now I'm going to put that big square root. So the square root of 0.188 times, or maybe parenthesis 1 minus 0.188, parenthesis divided by 90, and then close it. So notice here, and you could see my keys down here, that what I pressed. But notice I have this square root parenthesis, and so this big parenthesis closes the square root. And so this is the numerator, and that's the denominator. So be careful with the parentheses, and then hit paste. And then enter. And so notice it calculates it for me, and it's 0.4806. So let me go ahead and drag that over here. And so there it is. So it would be 0.4806. So there is, I guess let's write this out. What does this mean, right? So there is a 48.06 chance that a randomly selected, a random sample of 90 children, right, ages 6 to 11, um, there is a 48.06% chance that a random sample of 90 children has a proportion of at least 19% are overweight. So there is, and I apologize for this kind of scribble. I'm getting used to the tablet still, so because I write small naturally, so I apologize. There is a 48.06 chance that a random sample of 90 children, because remember we're taking a bunch of samples, right? So if we randomly selected this one sample of 90 children, that it has a proportion of at least 19% are overweight. So that's kind of like a thought. Okay, so now in this last part, in part B, it talks about a random sample of 90 school-age children still, but it results in 24 overweight children. So what would you conclude? So here we're kind of picking at this, right? So let me go ahead and mark the normal curve as usual. And then I'll go ahead and put 0.229, 0.27, 0.312, 0.147, 0.106, and then 0.064. And then 24 overweight children, well, okay, so I know that my P is 0.188, right? I do know that P hat can be given as x over n, where n is given to be 90. So I'm looking at specifically out of the 90 children I selected in my sample, how many have the characteristic that they're overweight? Well, they told me 24. So I could go ahead and put 24 over 90 and find this sample proportion that corresponds to 24 children being overweight. So if I put this in the calculator, I'll round to 3 decimal just to be consistent. So we get 0.267. And so let's mark 0.27. So let's mark 0.267. Where is that? So 0.267 is pretty close to 0.27. So I'll mark it here. Okay, that was our p hat. And then what would you say to that? Because look, there's a little tail left over here. Well, maybe we can find this probability. What is the chance? What is the probability that a randomly selected sample of 90 has 24 children overweight? That's what we're really asking. Like, what are the chances here? The chances, right? That the sample that I randomly select out of all these samples of 90 in the world, I grab this one sample of 90 and 24 are overweight. What are those chances? So the probability that the sample proportion would be more than 0.267 is equal to, and again, we could do the normal CDF here. I guess I could just copy this. Let me go up, hit enter. And then I would go here. And then I'm going to the right still. So let me go ahead and just insert 267. And then I'll just delete those two. Enter. So we get 0.0275. Right, and then I'll go ahead and drag this over and highlight. Yeah. Okay, so what are those chances? So that means that there is a 2.75% chance that a sample of 90 children are 24 of them are overweight. So here we always say the barrier is 5% for to be unusual, because I mean, if it's less than 5%, it pretty much is unusual. And so that's just a rule of thumb with statisticians. And so, and we can say like 2.75% chance. I mean, we can say that this is unusual. And again, this comes again from sample variability. You just happen to randomly select a group of 90 children in which had a little more overweight children than the other samples. And that's why we take a lot of samples. So this is why sampling distribution is so important. We take a lot of samples and find the means of the means and the standard deviation of the standard, because we know sample variability can affect the population assumptions. Okay, so the answer to this question is, what might you conclude? So I would conclude that there is a 2.75% chance that a random sample of 90 children, that in a sample of 90 children, 24 of them are overweight, or at least 24 of them are overweight. And I would also conclude that this is unusual.